Okay, we're factoring expressions, and we're going to talk now about factor method number 5, which we call grouping method. The main idea of grouping method is, as the name it tells you, we need to divide the expression into groups and then we factor by parts. This method is normally used when we have 4 terms or more. So let's try to see how we use this method. If you notice, the description is that you divide into groups and then you factor. So there is no limit or restriction to which method you can use. You can use any of the previous 4 methods in order to factor, and there's no problem with that. Grouping method requires you to use other methods. So let's see how we can apply this. Factor the expression. So in this example, we have 4 terms. So what do we do in this case? Well, we make 2 groups. These 2 groups. And what we're going to do is we're going to factor each group individually. Yes. So for those 2 groups, I'm going to try to find something in common. What do they have in common? So the first group has letter A in common. If you notice, I'm trying to use method number 1. I'm trying to use greatest common factor in here to see what's repeating and take it out. So in this first group, what's repeating is the A. If I take the A, then I'm going to have C plus D inside parentheses. Now that's only with the first group. Now I'm going to focus on the second group. What is repeating on the second group? Well, the B is repeating, so I'm going to put plus B. That's the thing I'm going to take outside, and I'm going to have C plus D. So if you notice, I'm factoring by parts. Okay, I'm factoring one part and then I'm factoring the other part. Once I've done that, I should be able to factor the entire expression completely now. If you notice, the parenthesis is now repeating. I have C plus D on one of the terms, and I also have C plus D on the other term. So what I'm going to do is I'm going to factor C plus D. C plus D. That's what I'm going to take outside in the parenthesis. And I'm going to open a parenthesis and I'm going to copy what is left. If I take the parenthesis C plus D, what's going to remain is A plus B, as you can see. So I'm going to put A plus B inside parentheses, and that's it. I finally factored the expression because I have 2 parentheses that are multiplying. Okay? The idea is we need to convert this into a complete multiplication, which it is in this case. So let's see more examples. 4x raised to the power of 5 plus x raised to the power of 4 minus 12x minus 3. So what we're going to do here is the same idea. We're going to group and we're going to see if we can take out things that are repeating. So in this first case, x4 is repeating. So I'm going to take out x4. If I do that, what's going to be left is 4x plus 1. That will be for the first group. Now on the second group, what is repeating? I can see that what's repeating is minus 3 because minus 12 is minus 3 times 4. And I also have a minus 3 in here times 1. So what I'm going to do is I'm going to take out the minus 3 that is repeating. So minus 3 is going to go outside. And if I take that minus 3, what's going to be left is 4x plus 1. Now that I have factored each group, I see that I can now factor the entire thing because the parenthesis 4x plus 1 is repeating now. So it's kind of like the parenthesis is going to start to repeat in some cases. Okay, in most of the cases, you're going to have a parenthesis that you can take outside. Is this going to happen all of the time? No, not necessarily. But it is something that we can use. So x4 minus 3. Yes, and that will be how we factor this using grouping method. Yes. If you decide to try to factor this using square root of 3, then that will be also a possibility. Square root minus square root of 3, well, plus square root of 3, and x squared minus square root of 3. That could be something that you could do, but we're going to leave it like that because we're going to assume 3 does not have a root, so we're going to leave it like that. Yeah? Unless it's completely necessary, we're not going to try to get the square root of something that does not have a square root. So let's see another example. Okay, example number 3. In this case, if we make these 2 groups, I can take out the x on the first group, but there's nothing in common in this other group, so I'm kind of like screwed in here. I need to find a different way of grouping. It's not going to work grouping like I did before, so find a different way of making the groups. Well, we could make a group of 3 in here, and this one could be a solo player or something like that. We could leave this one to wait. if we do that, you're going to see that this thing is a perfect square trinomial. So you can use method number 4. Or you use method number 3. You factor the trinomial and then you simplify it. And you're going to see that you're going to get x plus 5 squared. Okay? So that will be the factorization of this. Now, minus 16y squared, you just copy it because you cannot do anything yet. But if you notice, I have two things here that are squared and are subtracting. That will be method number 2, the one I can use. Okay, I can use method number 2 in here, difference of squares. How do you use difference of squares? Well, you open parentheses and you get the square root of both terms. The square root of this thing will be x plus 5. Yes, the square root of 16y squared will be 4y. So I'm going to put them with plus, so plus 4y, and I'm going to put them with minus, so minus 4y. And that will be the answer for the exercise. Okay, that's how we factor this type of exercises. So the group that we had to choose in this case were a little bit different. Now let's see this one. In this case, I could factor this, and it will give me 2x plus 3 and 2x minus 3. And I see that the 2x plus 3 on this other dude is going to be repeating, so I'm going to be able to take it out. So you kind of have to make a plan. Make a plan on how you might factor this thing. So I'm going to make two groups like this. Okay, this one's going to be a solo, and the first two are going to make this group. If I do that, then I know I can use difference of squares on the first two. If I use difference of squares, I will get the answer 2x plus 3 and 2x minus 3. I copy the other one. And if you notice, now the parenthesis 2x plus 3 is repeating. So I can factor the entire thing. I just need to use method number 1. If you notice, again, this method requires you to use several types of methods depending on the exercise. So I'm going to take out the 2x plus 3 because that's what's repeating. And inside parentheses, I'm going to put the other things. 2x minus 3, because there's nothing else right next to it. I don't need to use the parentheses for 2x minus 3 anymore. So I just put 2x minus 3. And what is left from this other thing, if you notice, like the 2x plus 3 is eliminated because I took it out. So what would leave me with is 2x minus 3 and plus 3y. So I'm going to put plus 3y in here. And that will be the answer for this exercise. Let's see a final example. Number 5. So what can we do in this case? Same thing as we did at the beginning. We make two groups. And you can tell that the first group is repeating the x, and the second group is repeating the b. So we're going to do that. We're going to use method number 1, and we're going to take out what's repeating. So on the first group, I'm going to take out the x, while on the second group, I'm going to take out the b. Once I do that, you're going to see that there's a parenthesis that is repeating on both parts, so I can factor the entire thing now. I'm going to take out the x plus a that is repeating. Okay, x plus a that is repeating. I'm going to take it out, and what's going to be left is x plus b. We finally solved this exercise. So grouping method only focuses on one thing. You make groups, and then you factor by parts.